let's look at this. Okay, x0, x1, etc. IID Gaussian with zero mean and variance sigma squared. What I'm going to do is I'm going to do this. Okay, I equal to 0 to infinity xi. Okay, so I'll just use phi I of t. What is phi I of t? This is a set of orthonormal functions. You know what an orthonormal function is? Functions are? Huh? Can somebody tell me what is an orthonormal function? What is an orthonormal function?
It's orthogonal to all other functions. And
What do you mean by that? Orthogonality means what?
Integral
of
phi
Yes.
I.
yeah.
Right? So integral of phi I of t times phi j of t dt over a period is 0, right? For all I not equal to j. If I equal to j, then it will get 1. That's called an orthonormal functions. Right? Where is it used? Fourier series, right? For example, complex exponentials with the integral multiples of frequencies, it corresponds to an orthonormal, well, orthogonal functions. When you normalize it, you'll get orthonormal functions, right? So essentially, you do a Fourier series, you write the Fourier series expression with Fourier coefficients being drawn from IID Gaussian with zero mean and sigma squared variance. Then we get a Gaussian process. That's one way of constructing a continuous time Gaussian process. So far we have looked at a discrete time Gaussian stochastic process or Gaussian processes, right? This is how you define or get a continuous time one. Okay, so we will see how to do that and what are the consequences and what happens if you pass that through a filter. So some of these things we will quickly go over, and then we will start Wiener process. So I want to do Wiener process in slightly more detail this time. Okay. Yeah. So once we do that, we will move into Markov chains by hopefully by not by the end of next week or the week after that. We'll start Markov processes. Okay. Is that fine? This sort of covers wide spectrum of tools that you will need as a researcher. Okay, you need Poisson process, you need Gaussian process, you need Wiener process, you need Markov process or Markov chains, right? So all these are very useful tools in engineering, especially electrical, that too in signal processing, communications, and machine learning. Okay, so I'll stop here. Any questions? Yes, any questions? Ayush, you have any questions?
No, sir.
Yeah, maybe I'll just quickly correct this. What went wrong? Is this correct? X of n plus 2 is alpha times x of n plus 1. I think this is W of n, right? It's not, yeah, it's, let me just write the way I have written this. W of n plus 1, you have n. So n plus 1, this is correct. Okay. And alpha, x of n plus 1 is alpha square times x of n, that's correct. Plus alpha times x of w of n, that is correct, and w of n plus 1, this is correct. So x of n times this is correct, alpha times x of n w of n, times alpha, this will be w of n plus 1, x of n times w of n plus 1, which is 0. X of n times w, x of n has w of n minus 1, so this is also 0. So we only need to take alpha squared x squared of n. So this is, so this gives me alpha squared expected value of x squared of n. So this is nothing but alpha squared expected value of x squared of n is what? This thing, right? Each square I have to consider, but the cross term will be 0. So w squared, the first term squared is sigma squared. This is alpha squared is sigma squared, and so on, right? So that's what we have. So I think that's fine. Yeah. Alpha squared, sigma squared, and you have, sorry, this is 1 alpha squared, alpha for 4, alpha 2 power n minus 1 sigma squared. So now alpha squared sigma squared 1 minus al 2n divided by 1 minus alpha squared. Okay, this is fine. You need not check. Okay. Okay, I'll stop here then. You know the mistake, right? So it should be squared alpha power 4 because we are squaring it. Okay, take this as an exercise and figure out. Okay. Any other
Hello,
question?
sir.
Yes.
Sir, can you go to that slide?
Yes.
The x of n, the above. Here, x of n equals w.
Correct. Hmm.
Down, sir.
Hmm?
Still down.
Hmm.
This one.
Hmm.
Sir, here we can use the fact that since wn minus 1, n minus 2 are independent,
Hmm.
we can use the since we know that variance of sum of random variables, independent random
Of course,
variables.
we have done. Yes. So
We can use. We could have used it directly here. No?
the variance of the sum is nothing but the sum of the variances. So this will give me sigma squared. This
Yeah.
whole thing will give me alpha squared sigma squared, and this will give me alpha power 2 times n minus 1 sigma squared. So when you add them, you get that expression. It's a um, geometric series, right, with the alpha squared term instead of alpha. So okay, that's how you get that expression. So you can generalize that. It's pretty straightforward. Okay. Any other questions? So we will have another quiz or whatever you want to call it, next time, whatever. So not the coming week, the week after that. Okay. I will let you know by Tuesday, but start preparing for that. Okay. The syllabus will be whatever I'm going to teach till the end of next week. After quiz, sorry, whatever that the first chapter was there for quiz. So after that, the second chapter will be there for the Poisson process and all that, plus the Gaussian. So that will be there for the next quiz. Okay. Okay. Yeah. I'll stop. Thank you. Any questions?
Thank you, sir. No, sir.
Okay.